We're in 3.8. It's number 5 from my MATLAB. So differentiate implicitly to find dy by dx, then find the slope of the curve at the given point. We're going to do the slope. It's like a two-part question. First, we're going to find the derivative. And then, so it's like part A and then part B, then find the slope. So we have y squared minus x to the third is equal to 8. And notice that what we're finding is dy by dx. So this is very important. So if we're finding dy by dx, it means that we're taking the change with respect to x. Keep that in mind. So we're taking the derivative with respect to x. So what we're really doing is we're taking d by dx of y squared minus d by dx of x to the third is equal to d by dx of 8. It's an additional problem, so we take the derivative of each individual part, just as we've been doing all semester, right? Now, let's start from the right and work our way left. What's the derivative of 8? 0. I agree. Right? The derivative of any constant is always going to be 0, right? How about the derivative of x to the third? Three x squared. I agree. Kind of prepping the next problem. So 3x squared. How about the y squared? What's the derivative of y squared? How do you get that, Martha? Two y. All right, so closer. So 2y. Now, if you recall, like last class, we were saying because the variables are different. Notice that these two variables are different. One is x and one is y. We also have to take the derivative of y. Remember, going back up here, we're saying, what's the derivative of y again? The derivative of y is dy by dx. So yes, we had, if you look at this example here, the same thing we're doing again today. The derivative of y squared is 2y times dy by dx. Because the variables are different. Always keep that in mind. So this we're going to have times dy by dx. Now for the x, why don't we write, here you'll notice the variables are the same. So when we take the derivative here, theoretically it's dx by dx. Because it's a change in x over the change in x. See, this delta here is like the change in x over the change in x. Now what's dx over dx equal to? What is this equal to? Come on. It's not as complicated as you're thinking. What is 5 over 5 equal to? Can you hear me? Yeah. What is x over x equal to? Yeah, what is dx over dx equal to? 1. So all of this is equal to 1. This is why we don't need to write a dx by dx in this section. Only when the variables are different, like we're taking the y with respect to x, we need to include it in a problem. So here this is 2y dy by dx minus 3x squared is equal to 0. So please do not forget to include, that change of variable for the second when the variables are different. Now, how do we solve for dy by dx? Well, we can move this over. So we have 2y dy by dx is equal to 3x squared. And then we can divide everything by 2y. So dy by dx is equal to 3x squared over 2y. So that would have been part A of your answer. Find dy by dx. Now part B says find the slope at the given point. And the given point is 2 and negative 4. So we're finding m at 2 and negative 4. So m is equal to 3 times 2 squared over 2 times negative 4. So notice we have to plug in both the x and y into this problem to find the slope. So what do we get for this? That looks right to me, Michael. So this will be 12 over negative 8, which reduces to negative 3/2. We'll get a next problem. So number 6 and number 7 is somewhat similar. Let's do number 9. Number 8 is similar to number 9, so I'm going to do number 9. And after this one, we'll probably just move on. Let's say there's anything drastically different. All right, what are we going to do now? Someone help me with this, please. I don't know what to do.
We can start off by finding the derivative.
All right, so we're going to find a derivative. Very good. 1 second here. I'm changing one of the homework questions. I notice. Mm. All right. So we're going to find a derivative. I agree. So we're going to find a derivative of the whole function with respect to what? What's going to be on the bottom? Come on, what's going to be on the bottom of this derivative? But that's very important. dx, thanks, Damien. How do we know that? I mean, they tell us explicitly that we're going to find the derivative with respect to x, right? So we want dx on the bottom. So we're taking the derivative with respect to x. So we're taking d by dx of x squared y minus d by dx of 4x to the third minus d by dx of 4 is equal to d by dx of 0. And we can work our way from right to left as we did before. So what's the derivative of 0? So let's 0. What's the derivative of the 4? 0. So those two actually goes away. What's the derivative of 4x to the third? 12x squared. 12x squared. I agree. Now here, let's look at this piece now. So we're going to find the derivative of x squared y. Be careful on this. I don't know if you did it already, but this is a little longer because this is a product rule problem, right? This is x squared times y. So I have to go back to that product rule, where if we have f and g, the derivative of f and g is f prime g plus f times g prime. So what's f prime? If f is equal to x squared, what's the derivative of x squared? 2x times g, which is y, plus f, which is x squared, times g prime. And what is g prime equal to? dy by dx. Very good. All right, so don't forget that, because these variables are, once again, they are different. And it's when they're different like that, then we have that dy by dx into the problem. Now, what can we do? We're solving for dy by dx, so we need to get this by itself. So we could keep the 2x, well, let's not keep that. We could keep all of this, come on, this side, and we could move everything else, like this and this, over to the right side. So we have x squared dy by dx is equal to 12x squared minus 2xy. And then we divide everything by x squared. So dy by dx is equal to 12x squared minus 2xy over x squared. So that's the implicit derivative of the given function. Then they say find the slope at a given point, and the point is 2, 9. So we're going to find the slope there. So we're going to find m, which is equal to, we're using a point 2 and 9. So this becomes 12 times 2 squared minus 2 times 2 times 9 over 2 squared. What do you guys got for that? Anyone get an answer for this? Okay, sounds good. All right, so this is implicit differentiation. And the key point again is once we take the derivative of these variables that are different, you need to include that dy by dx in it. Any questions on that? Before we move on to the next section. No questions? Sounds good.